Good morning everyone, myself Dr. Sakti Prasad, and now here I am discuss the regression analysis in statistics part 2. Now in these lectures we have covered the four different type of solved examples. So now we start for the first question. Find the correlation coefficient between x and y when the line of regressions are 2x minus 9y plus 6 equal to 0 and x minus 2y plus 1 is equal to 0. Now the solution part, first we need to assumption. First we write the equation number, this is the equation number 1 and this is the equation number 2. Now the equation number 1 is converted the regression line of regression of x on y. Here we write the x equal to 9 by 2 y minus 3. Now after that we find the regression coefficient bxy is equal to 9 by 2. And now the similarly we find from the equation 2 is find the line of regression of y on x. Then we write the equation 2 is y equal to 1 by 2x plus half, and it gives regression coefficient y on x is equal to 1 by 2. And after that we find the regression coefficient of this, and after that we know that the correlation coefficient is the geometrical between the two regression coefficients. So here we write it is the properties of the regression coefficients. So we write the rho xy, this is the correlation coefficient, is equal to under root of bxy into byx. And now we write 9 by 2 into 1 by 2 is equal to 3 by 2 is equal to 1 by 5, which is not possible because the regression coefficient always lies between minus 1 to plus 1. Here the regression coefficient is 1.5, it is greater than 1. So our choice of the regression line is incorrect. Means that we change the assumption parts. So now in the next we assume that therefore the next assumption the regressions line of x on y is equation number 2. Here the equation number 2 x minus 2y plus 1 is equal to 0. Then we write here x equal to minus 2y minus 1. Then what is the regression coefficient? Here the regression coefficient is what? Bxy is equal to 2. And now the regressions line of y on x is converted. The y on x is of this line, equation number 1. This is a 2x minus 9y plus 6 equal to 0. Now we convert is y on x. Therefore y is equal to 2 by 9x plus c. This is the next assumption part. This is the we assume that this equation we assume that of this part. So now here what is the regression coefficient of in y on x is equal to 2 by 9, and after that we write the rho xy is equal to under root of bxy into byx means that it is coming 2 by 3, means hence the correlation coefficient means that our choice here the our assumption here the our assumption is correct. Our assumption is correct because correlation coefficient is lies between minus 1 to 1. So then hence the correlation coefficient between x and y is 2 by 3. So now we move for the next question. Here the next question is what? The two regressions line of the variable x and y, x equal to 19.13 minus 0.87y. This is the equation number 1. We take the equation number 1 here. And y is equal to 11.64 minus 0.550. X is taken the equation number 2. Find the mean of x and find the mean of y and then the correlation coefficient between x and y. So here the regressions lies in given and then we need to find the correlation coefficient here. So first we know that the regression means satisfy the regression lines. That's why we take the mean of the equation 1 and we take the mean of the equation 2. We write x bar equal to 19.13 minus 0.87 y bar, and y bar is equal here the equation from equation 2 y bar equal to 11.64 minus 0.50 x bar. And now these equations can be write in this form: x bar equal to 0.87, y bar is equal to 19.13. And now this is, we can write 0 to 0.50 x bar plus y bar is equal to 11.64. This is, we have considered the equation number 3 and equation number 4. And after solving the equation 3 and 4, we get the values of x bar. This is the simultaneous linear equations. So we solve this equation x bar and we get the values of x bar is coming 15.934 and y bar is equal to coming 3.67. And now from 1, and this is part is over, then the next is find the regression, find the correlation coefficients with based on the regression coefficients. So from the equation 1, what is the bxy? Here the regression coefficient x1y is given minus 0.87 from the 1, and from 2 byx is given minus 0.50. And after that we find the rho xy is equal to under root of bxy into byx is equal to under root of minus 0.87 into minus 0.50. It is coming, this is the plus sign, minus minus plus is coming under root of 0.435. After that we finding the value is coming minus coming 0.6595. But we have substitute here negative, we taken the negative sign because both the regression coefficients are negatives. So this is the, this properties is coming from the regressions of coefficients. So now we move for the next. Now the next question is find the correlation coefficient and the regressions line of the following data. Here the data is given, x and y is given, and now first we identify how many total number of pairs is given. First we n is equal to 7 is given, and we know that what is the, we have used the direct methods for finding the correlation coefficients. Now this method we have discussed in the correlation coefficient in a statistics part 1. So please go and learn, guys. So here we write directly summation xy, capital XY by under root of summation x square into summation y square. Here is capital X is equal to x minus x bar and capital Y is equal to y minus y bar. And first we need to find the x bar here. How to find the x bar? 1 by n summation x, we need to 5 plus 7 plus 8 plus 10 plus 11 plus 13 plus 16 and divided by the total number of the pairs. Here is 7. We can write the, we can find the values of x bar is 10. And similarly we find the y bar. Y bar is equal to 1 by n summation y is equal to 154. 154 is coming this plus this plus this plus this plus this plus this plus this. It is coming 154 divided by 7. It is coming 22. And after that we write here x, capital X is equal to x minus 10 and capital Y is coming y minus 22. So now we need to find the next values. We construct the table. We construct the table here. Here we construct the table. Here the construct the table xy is given already. Then we need to find the x bar. Here the capital X bar is equal to x minus 10 and y bar is equal to, here is coming, this is the formula is given. Here is coming y, capital Y is equal to y minus 22 and need for what? Xy. That's why we can construct the one column xy, and after that we need for summation x square. That's why we construct x square, and after that we need for the y square. Here we write for the y square, and here x is given, y is given. After that we calculated x minus 10, 5 minus 10 is minus 3, minus 5. 7 minus 10 is minus 3, 10, 8 minus 10 is minus 2, 10 minus 10 is 0, 11 minus 10 is 1, 13 minus 10 is 3, 16 minus 10 is 6. And similarly we find the capital Y, small y minus 22. We need for the 33 minus 22, it's coming 11. Here the 30 minus 22, it is coming 8. Here is 28 minus 22 is coming 6, 20 minus 22 it is coming minus 2, 18 minus 22 it is coming minus 4, 16 minus 22 it is coming minus 6, and 9 minus 22 it is coming minus 13. And now need to xy, just we multiply this column, this and this column, we coming from the minus 55, 20, minus 25, minus 12, 0, minus 4, and 3 minus 6. 3 into minus 6 is equal to minus 18. 6 into minus 13 is minus 78. And after that we need for the x square, then this column is squaring this side. 5 is square, minus 5 is square 25, minus 3 9, minus 2 is square 4 0, 0 square 0, 1 is square 1, 3 square 9, 6 is square 36. And similarly we find the y square, here is coming 121. And after that we need to find these values. Here we go for this. So here we need for the summation x equal to 70 and summation y is equal to 154. Here the summation xy is equal to minus 191 and summation x square is equal to 84. After reading these values, after adding these column values, we get the summation y square 446, and we know that the formula, so rho is equal to summation xy, capital Xy is under root of summation x square into summation y square. Here we substitute the values. Summation xy is what? Minus 191. Under root summation x square is 84 and into summation y square is 446. And after calculating, we get the values of rho is equal to minus 0.9868. This is the correlation coefficient of this. And after that, we go for regressions line. According to the question, find the regressions line of y on x. Regressions lines means that we need to find the two lines. First we need to find the y on x, and second one is need to find the x on y. Depends upon you which one is find first. So here we write the formula first. Here the y minus y bar is equal to rho sigma y by sigma x bracket x minus x bar. First we have identified how to find these values, this particular values. Here we write the sigma rho sigma y by sigma x is equal to rho, and under root we write the sigma is a standard deviation. Here we write the under root summation of y square by summation of x square, and after that we write rho is what? Rho we have already find, this is coming minus 0.9868. Under root of summation y square is already we have covered here. Summation y square is given like this. Here is 446 and summation x square is 84, and after calculating it is coming, this part is minus 2.2738. Here we substitute y minus y bar. According to the question we have, first we find the y bar and x bar. Here is y bar is coming 22 and now x bar is coming 10, and this portion is also coming minus 20 minus 2.2738. And after that we can write in a simplified form y is equal to minus 2.2730x plus 444.738. This is the regression. This is the regressions line of y on x. Now we move for the next. What is the regression? What is the equation of line of regression of x on y? First we need to write the formula. X minus x bar is equal to bxy bracket y minus y bar. Sorry guys. So before that we find bxy. What is the mean bxy? It is the regression coefficient of x and y. Means that we write the rho sigma x by sigma y is equal to, we write the rho under root of summation x square by summation y square, and after that we write the values. Rho values are given minus 0.9868 and summation x square is 84, summation y square is given 446, and then after calculating it is coming from bxy is minus 0.4283. Here we substitute x minus x bar is 10. Here is bxy is already we have find here minus 0.4283 bracket y minus y bar is 22. Now after simplify it is coming what? It is coming x equal to minus 0.4283y plus 19.4226. This is the regressions lines of x on y. So this is the result for these questions. So now we move for the next question. Here we find the two random variables have the joint probability densities function is given 1 by 3 bracketed x plus y, and x lies between 0 and 1 and y lies between 0 and 2. Find the correlation coefficient, and then we find the two regressions line. Now first we know that what is the correlation coefficient, what is the formula for correlation coefficient. Here is the, it is based on the continuous random variables, and it is given the joint probability density functions. So we need to write the rho is equal to covariance of xy under root sigma x square into sigma y square. We can write here covariance of xy by sigma x into sigma y. Now here we taken the covariance term in the expectation term form, expectation of xy minus expectation of x into expectation of y, and sigma x is already some under root expectation of x square minus expectation of x square, and sigma y is under root of expectation of y square and expectation of y whole square. And after that we need for what, expectation of x. How to find the expectation of x? Here we write the expectation of x is minus infinity to plus infinity x into cap, if x into marginal probability density function of x, we have written this f of x dx, and expectation of y is minus infinity to infinity y marginal probability density function of y dy. Now we need to first we find the value of marginal probability density function of x and marginal probability density function of y. So first we need to find these values. Here the f of x is the marginal probability PDF of x is minus infinity to plus infinity. Here is the joint PDF into dy, and we can write here 0 to y lies between 0 to 2. Just why we can write here 0 to 2, and this is the function is given 1 by 3 x plus y dy. And now after integrate it is coming 1 by 3. Here we integrate with respect to y. Here the xy plus y square by 2 is y is equal to 0 to 2, and after substituting this values is coming from what, 2 by 3 bracketed x plus 1, and here is x lies between 0 to 1. And now the similarly we have find the next marginal probability density function of y minus infinity to plus infinity, and here we write for the joint PDF dx is equal to, we write the limit of we write the integration limit of x is 0 to 1 according to the question, and here we 1 by 3 bracketed x plus y dx, and after simplify 1 by 3 integrating these values x square by 2 plus xy, y as a treated as a constant, and now we write for the x equal to 0 to 1, and after simplify it is coming 1 plus 2y by 6, and here y lies between 0 to 2. And now after that we need to find the x bar. Here we need to find the x bar. Here the x bar is equal to expectation of x. Now we have write the formula integration minus infinity to plus infinity x into marginal density function of x dx, and now we write the value 0 integration limit of x 0 to 1, here is x, and marginal probability density function of x is 2 by 3 x plus 1 dx, and we write here 0 to 1 2 by 3 bracketed x is for the inside here x square plus x dx, and after simplify it is coming x cube by 3 plus x square by 2, and then we put the limit x equal to 0 to 1, it is coming what, 5 by 9. And now we similarly we have find the expectation of x square, because we have required the expectation of x square in a variance terms. That's why we can find out the expectation of x square. Here the similar patterns, just we here is coming x square minus infinity to plus infinity x square. Here is the marginal probability densities function dx, and now we write 0 to 1 x square into 2 by 3 bracketed x plus 1 dx, and after simplify we get the result is 7 by 18. So now we need to find the sigma x square here. Sigma x square is what? This is the sigma x square. Variance of x is expectation of x square minus expectation of x ka whole square. We have already find the values. Here is the 7 by 18 by minus 5 by 19 ka whole square is equal to 13 by 162. And after that we go for the similarly we find the values of y bar. Here is y bar is equal to expectation where y. Here we write minus infinity to plus infinity y into marginal probability density function of y dy, and we know that what is the limit of y is according to the question is given 0 to 2, and y into is we have already find before that 1 plus 2y by 6 into dy. Here we write 1 by 6 and we write in inside in multiply by y. Here is coming y plus 2y square dy, and after simplify and then we substituting the limit of y, then we get the 11 by 9. And similarly we find the expectation of y square. Just here we take the values in y square, that is coming the values of 16 by 9. So now we need to write the variance. Sigma y square is equal to expectation of y square minus expectation of y ka whole square is equal to 16 by 9 minus 11 by 9 ka whole square, and after calculating it is coming 23 by 81. This is the variance of y. And now the need for the covariance in a covariance point is required for the expectation of xy. That's why we can write here. That's why we can write expectation of xy is equal to minus infinity to plus infinity minus infinity to plus infinity xy into, here we write the joint PD of dx and dy. And first we integrate here with respect to x. That's why we can write here 0 to 1. The limit here is given x equal to 0 to 1, and here is limit y 0 to 2, but here limit is constant, so there is no need to change of orders. So we can calculate integrate with respect to x first, yeah, y first. Here is no problem. So now in this question we have taken the first integrate this with respect to x. That's why we have taken like this. Here is 0 to 1 x square plus xy dx, and now we outside of y and dy, and after integrating with respect to x, here x cube by 3 plus x square by 2, y as a treated as a constant, and now we take x equal to 0 to 1 dy, and when we substitute these values it is coming 1 by 3 plus 1 by 2y, and after that this the whole integration in coming in y, and now we need to simplify. This is the simple integral. So after simplify it is coming what? It is coming the result for what? 2 by 3. The expectation of xy is coming 2 by 3, and then we move for the correlation part. Here we move for the correlation part. Here the move for the correlation part. Here the correlation part is what? Covariance of xy is equal to expectation of xy minus expectation of x into expectation of y. Here we already find these values are 2 by 3 minus expectation of x is 5 by 9 and expectation of y is 11 by 9. After calculating it is coming minus 1 by 81. And now we need that rho is equal to covariance of xy is under root of sigma x square into sigma y square. Here we write minus 1 by 81, covariance is coming minus 1 by 81, and under root sigma x square before is coming 13 by 162 into sigma y square is coming 23 by 81. After calculating it is coming what? Minus 0.082. This is the covariance, this is the regression coefficients. So now we need to find next. Here we need to find the regressions line of x on y. So just we write the formula here. X minus x bar is equal to bxy bracketed y minus y bar. And now here we write x, and x bar is already found before x 5 by 9. And now bxy, this is the regression coefficient of x and y. We can write is the covariance of xy divided by variance of y. Bracketed y minus y bar is 11 by 9. And now after that we write x minus 5 by 9 is equal to covariance term we have already find, it is coming minus 1 minus 1 by 81, and variance of y is already coming, sigma y square is coming 23 by 81 bracketed y minus 11 by 9, and after simplify it is coming the regressions line of x and y, which is given here. So now we similarly we find the regressions line of y on x here. Y on x we write for y minus y bar is equal to byx bracketed x minus x bar. Here the byx is right in the covariance of xy by divided by sigma x square. We have this part is already is covered in the regression coefficient in a statistics regression analysis in a statistics part 1. So please go and learn how will come this formula. So here we write for y minus 11 by 19, and here we write the minus 1 by 81 divided by 13 by 162 bracketed x minus 5 by 9, and after simplify we can write the line is y minus 11 by 9 equal to minus 2 by 13 bracketed x minus 5 by 9. This is the regressions line of y on x. So now thanks for watching my video. So please like, comments and subscribe my channel.